Okay. Right. Sorry for the delay. Okay. So we just resume our lecture. Okay, don't worry. This is recorded, so you guys can, if let's say you miss this lecture, any lecture, it will be posted on eLib. Okay, and actually, I don't make it as compulsory for you to attend virtually on real time. So if you have problem to access it, to attend, it's fine. Okay, as long as you later, anytime later, you access, you watch the recorded lecture and you got what I teach for that particular class, that would be okay. Okay, so I don't make it compulsory because I understand on your side there might be lots of things, lots of uncertainties, yeah, during this online learning. So we are not that really strict, yeah. So don't worry about that. Okay. All right. So we resume our lecture. We are still in LU2. So this LU is quite long. So today we just cover one lecture, lecture 4. So the topics that we are going to discuss today, there are two main topics, subtopics. The first one is confidence interval, and the second one is T distribution. Okay, so previously under lecture 2, we have talked about binomial, and then Poisson distribution, and then followed by normal distribution. We talk about sampling distribution as well after that, and also central limit theorem, right? So that covered in lecture 2 and lecture 3. Lecture 2, 3 and 2 and 3, sorry. Lecture 2 and 3. Okay, so in lecture 4, we're going to cover confidence interval and T distribution. So this is the outline. So for the first subtopic, confidence interval, there are two situations that we're going to discuss. Confidence interval when the standard deviation of population is known, and the second situation is when the standard deviation of the population is unknown. Okay, so there are two situations that we would cover under confidence interval. And the second subtopic is T distribution. Okay, so let's have a look first at the first subtopic. So confidence intervals. So what is confidence interval? So confidence intervals are frequently used as interval estimate of a population parameter. Okay, so the word interval actually refers to something to do with the range. Okay, so it's like a limit from what to what. So that's what interval is. So in statistics, it is used as interval estimate. So why it is said as interval estimate of a population parameter? So we are still talking about population because in statistics, we are always concerned with the population. And in order to estimate whatever the population that we are analyzing, we use sample. Yeah, okay, we talk about it later. But here is as interval estimate of a population parameter. Parameter, it can be anything that we measure within that population. Okay, right. So a pair of limits or confidence intervals are a pair of limits or bounds to indicate the range within the parameter is estimated to be. So see the limits or bounds. So means that it is from the mu, let's say the mean of the parameter, the population is from A to B. So this is what is meant by the whole thing here is called confidence interval. So this one you can see this is the limits. This is the limits. Means that you know it's from where to where, or limits or bounds is the same thing. Okay. Research literature commonly report 95% confidence interval. Okay, so normally in statistics, the statistician have set certain range, right, which is already decided because of the relevance. I mean, they have investigated the relevance of that for example, 95%, 99%, or 90%. So that is the standard interval used in statistics. Okay, so yeah, so normally it's 95% confidence interval, right? So the 95% confidence interval is calculated in such a way that under repeated sampling, it will contain the true population parameter 95% of the time. Okay, so why, so that one, okay, why we need that confidence interval in anything, in any measurement? Why? Because in any measurement, we cannot really guarantee that our measurement is 100% correct. Yeah, let's say you are measuring the size of the diameter, let's say the diameter of insects, whatever the insect, within a certain area. So that area you define as the population, and within that population you have samples whereby you have, let's say, station, different station where you collect the insects and then you measure it. So whenever you measure it, whenever we measure anything, right, we cannot guarantee that whatever we measure is 100% correct. There might be errors, there might be inaccuracy, right? Let's say we measure, maybe we are mistaken by few centimeter or few millimeters, right? And then from one sample to another sample, we also, I mean that is the nature of human. We always we are not perfect. We may commit some errors. Okay, so that is the thing that we consider in statistics. We cannot assume 100% accurate. So that's why 95%, I mean, out of 100% the data, let's say our distribution data is something like this, right? Okay, it means that it covers 100% of the things that we measure, but we cannot say that it is perfect, you know. So if, let's say, we say it's perfect, then we don't have this 95%. So we have to allow some rooms for errors. Okay, so let's say this is the total distribution that we have. So considering the errors, human errors, technical errors, or things that we can't control. Yeah, errors in statistics, there are always errors, but of course we have to make sure that we minimize the errors. We don't want the errors to be that really much, but we have to also understand the nature that errors are inevitable. We can't avoid it. So we just can assume that out of 100% of our data, 95% could be true. Okay, so that is actually what is meant by when we say 95% confidence interval. So we are confident that 95% of our data is correct. 5% could be because of errors. Okay, so here is like 95%. This is what is covered by 95%. Whereas you can see that at the tail area here, this is what we allow for the errors. Let's say this is 2.5% on the right tail and 2.5% on the left tail. Okay, so 95% sits in the middle. The figure 95% is a measure of the confidence you have that the interval contains the true population parameter, as I said just now. So we are confident that 95% is correct, whereas 5% is are errors. So apart from 95%, 95% is the one of the common values used in statistics for confidence interval. So apart from 95%, statisticians also use the values of 90% and 99%. Okay, 90% or 99%. So it depends. We can define in our measurement which confidence interval that we want to use. Okay, let's have a look at some terminologies. Yeah, just to just now I explained the concept. This is what is defined in words. Okay, confidence interval is the range, positive and negative, within which your sample statistics is estimated to approach the true population parameter. Yeah, so the range, positive, negative, this one is referring to from, let's say, from what it is A and B. And then confidence level, this is interval. Interval means the whole thing here. The whole thing here. Confidence level is the probability that you are wrong, that the sampling error exceeds the confidence interval given. Usually the 0.05 level is chosen. Okay, so this one level is actually the error, actually, it denotes the errors. If let's say we have 95% confidence interval, then the confidence level should be 5% because 100 minus 95 is 5%. So that is the probability that you are wrong, that the sampling error exceeds the confidence interval given. Okay, it actually refers to the balance or the error. Okay, 5% in for the case of 95. So that's why this one, usually the 0.05 level is chosen for 95% confidence interval. Okay, so that is the two things, confidence interval and confidence level. So why do we need confidence interval? Okay, I've mentioned about it briefly. Sample mean is not a perfect estimate of the population mean. Okay, there might be errors. It is bound to be at least either a little bit too high or a little bit too low. For the estimate of mean to be of value, one must have some idea how precise it is. That is, how close to mean is the estimate likely to be. An excellent way to specify the precision is to construct a confidence interval. Okay, so basically, because of any measurement is not accurate, so that's why we need to just estimate within which it will be correct. Okay, so that is confidence interval and confidence level. Right now, let's move to the first situation where the standard deviation of the population is known. So there are two situations that we will analyze. The first one is when the standard deviation of the population is known, and the second situation is when the standard deviation of the population is unknown. Okay, so now if you see here, we are always concerned with population. Population, and we use samples to give an idea about the population. Okay, for example, like whenever we talk about unimass we define as a population, and then of course we have to, in order to get the information about unimass, we have to analyze the samples. We have to analyze the sample, where we define the samples as the faculty, because faculty are the subunit of unimass, right? So we have to analyze the data of the samples at the end, to give an idea about the population. So the same thing here. First, when we want to give a picture about the population, then we have to go to the sample, the samples. So here, the standard deviation is known. So what we should do, so remember, we want to construct the confidence interval. We want to find the range of the mean, whatever the parameter of the population, from what to what. Okay, this is actually the ultimate aim of the confidence interval, to find the range. Yeah? So what are the things that we need to know in order to construct a confidence interval? We should know what is the sample mean. Okay, sample mean. And then the value of Z, which depends on the level of confidence, and standard error of the mean. Okay, there are three things that you need to find out: the sample mean, the Z value, and the standard error of the mean. Okay, so let's go through first this thing before we go into an example. So if let's say we want to write the expression for the confidence interval, so this is in terms of this one, plus minus, okay, and this is the things that you want to find. Actually, this is the final form of the confidence interval that we want to find. So means that here, this is the population mean. This is the population mean. You just have to leave it in the form of symbol mu. And remember, mu is the mean of the population. And then for the lower limit, on the left side, we call lower limit. On the right side, we call upper limit. Yeah, because they are separated with this symbol, this one. Yeah? Okay, so the lower limit is given by the sample mean. X bar is the sample mean. This is sample mean. Okay, minus Z multiplied by the standard deviation. Okay, this is standard deviation. Standard deviation of the sample. Okay, standard deviation of the sample. And on the right side is actually the same. It's just the difference is the symbol of minus and plus. Okay, on the upper limit, X bar plus Z multiply with the standard deviation of the sample. Okay, so that is that is the expression of lower limit and upper limit. So what we have to find out from all of this is the value of the upper limit and lower limit. Okay, so we have to know what is the sample mean, we have to know what is the Z value, and also what is the standard deviation of the sample. So those values that we need to solve. Okay, so this is the summary of computation of confidence interval when the standard deviation of the population is known. So whenever we want to solve for the confidence interval, when the standard deviation of the population is known, these are all the steps. First, we have to compute the sample mean. This is sample mean, X bar. And then the standard deviation of sample. So sigma X bar. So this is the formula. And then we have to find the Z value. Okay, so how to find the Z value, I'll show later. And after we have find number one and until number 3, then we can solve the lower limit and upper limit, yeah, based on this formula. And at the end, we have to write this expression. Okay, so you get the value, the number actually for the lower limit and upper limit, and you just substitute into this term, and you'll get this population mean between what to what. Okay, so this is what is meant by the confidence interval. Okay, so the assumptions here is a normal distribution, standard deviation of the population is known, and the scores are sampled randomly and are independent. Okay, so that is the assumptions. So let's have a look at this example. Assume that the standard deviation of SPM verbal scores in a school system is known to be 100. A researcher wishes to estimate the mean SPM verbal score and compute a 95% confidence interval from a random sample of 10 scores. So the 10 scores are given here, okay, 320 to 780. So what are the informations that we get from this problem? So it is stated that the standard deviation of SPM verbal score in a school system. So this whole thing is actually a population. This is population. Okay. And the standard deviation is 100. Okay, so what we know is like the standard deviation is 100. So this is a random sample of 10 scores. So a random sample of 10 scores. So this is the sample that we want to analyze, right? And here are the scores. Okay, so now what we can do is that we can find what is X bar, right? So I mean, like, okay, let's have a look at the steps that we have to go through. So we want to find what's the confidence interval, right? The question asks this one, compute a 95% confidence interval. That's the question. So we know that the standard deviation is given 100. So we can apply this computation, yeah, because the standard deviation of the population is given. Okay, first we have to find what is the sample mean, and then followed by what is the standard deviation of the sample. Okay, and then we have to find what's the Z value. And we know that the question asks 95% interval. Okay, so how to solve that? The first question, the X bar. So the X bar is the mean of the sample. So you just add up all of these things, right? The number until 780 divided by 10, because there are 10. So you get the values. Okay, that is the mean of the sample. Okay, that's the first step. The second step is you have to find what's the standard deviation of the sample. Okay, so the standard deviation of the sample is equal to the standard deviation of the population divided by the square root of n. Okay, that's the formula of that one. Yeah. So the standard deviation of the population is 100. It's given here. Divided by the square root of the n of the sample, which is 10. Okay, this is n. Yeah, n of sample. So you will get the value of yeah. So what's the value here? 31.62, and this one is 530. Okay, so when you calculate, this is the value of it. So this is step 1 and step 2. Step 2. And then step 3, you have to find the Z. Okay, find the Z. Okay, how to find the Z? So it's given 95%. Okay, so you just imagine if you want to sketch the distribution on the Z tab on the Z distribution. Okay, so the 95% is in the middle here. This is 95%. So it means that the balance would be on the tail, isn't it? Okay, so because it is divided into 2, then 5% goes to both tails. So this one is 2.5% and this one is 2.5%. Okay, so if let's say we want to find on the Z, the Z value on the Z distribution. So now let's say we just consider one part because we know that it is symmetric. Okay, so this Z is the one that we want to find out. Okay, 95% divided by 2 is 95 divided by 2, that's give you, this one is 47.5% actually, right? If you divide by 2, then that's equal to 0.475 if you convert it into decimal points. So it means that now the area for the shaded area here is 0.475. So what is the Z value that corresponds to that area? If you refer to the table, okay, the Z table, I don't show it here. So the Z should be equal to 1.96. Okay, the Z should be equal to 1.96. So that is the Z value that you are looking for. Okay, so that is step 3. Okay, step 3, you got the Z value. Step 1 just now, the mean of the sample. Step 2, the standard deviation. Right now, step 4. 4 and 5, you want to find the lower limit and upper limit. Okay, using this formula. Okay, because you know already all the values. So you just substitute the values. Okay, so I just show on the samples given here. Okay, so this is the one that you are looking for. Lower limit and upper limit. Okay, for the lower limit, the average is 530 today. Okay, so this is the X, yeah, the X bar 530. Z is 1.96. Okay, you might substitute into this. The standard deviation is 31.62. You got this one, lower limit, and lower limit is minus. Okay, that's the difference. and for the upper limit is plus. Okay, the terms are similar. So this is the lower limit and upper limit. So once you got that value, then the last step, step 6, is to construct the confidence interval. Okay, so step 6. Step 6, construct the confidence interval. So you have to know that the term that you use in the middle here is mu, which is the mean of the population. The mean of the population. So this is the lower limit, this is the upper limit. Okay, so this is the final answer that you have to write. Okay, so remember, if you just end up with the values lower limit, upper limit up to here, and you don't write this one, you might lose some marks, because the question asks you to construct the confidence interval, not to just give the value of lower and upper limits. Okay, so the final answer you should reach up to here. Sorry, here. Okay, so it means that, what does it mean actually? I mean, if we relate back to the problem, so the 10 scores are these. So 95%, the accuracy actually lies between this value, 468 and 591. So that is where the 95% lies. Okay. So just now the person still cannot enter. I feel sorry for her, but I can't do much. I don't know how to.
She already entered.
Oh, okay. All right. Okay, that's good. Okay, so that is the answer. Okay, so that is when the standard deviation of the population is known. Yeah, confidence interval when the standard population is known. Any questions so far? It looks easy, right? As long as you familiarize yourself with these steps, 1 to 6. Okay, how to familiarize it? You have to practice a lot. Okay, so you know that what you want to find next and until you reach the confidence interval. Okay, so that is the first situation when the standard deviation is known. Okay, so here is another example. So the difference is only here is 99. Compute a 99% confidence interval. So what will be different is the Z value, because now if let's say it's 95%, then you have to sketch it, and you will find that 99% is here, right? So this is 99%. So the balance is 1%. So you have to divide the 1% into 2, which is here. This is 0.5%, and this one is 0.5%. Okay, so when you find the value of Z, 99 divided by 2, that's 0. In terms of the area, it would be 0.495. Okay, so when you find the area of Z that corresponds to 0.495, it will be 1. I think, where's the value? Z is 2.58. 2.58. Okay, so that value is 2.58. Okay, compared to just now 1.96, right? When the Z is when the confidence interval is 95%. So that will give you the difference, and the lower limit and upper limit will be different. Okay, so you can see that this one is the lower and upper limit compared to the previous example is 468 and 591. So means that this one is actually, it covers a little bit more. The data is from 448 to 611. This one is a little bit, this one is 468 and 591. Okay, so that is 99% confidence interval. So you have to, whenever you solve the confidence interval, take note of the values that the questions ask. It could be 90%, 99%, or 95%. So how it will differ, it will affect the Z value, because the area will be different. Okay. All right. So that's the first situation. The second situation is when the standard deviation of the population is unknown. Okay, this one is unknown. Unknown means that it's not given. So in the question, you will not find any information of standard deviation of the population. So from there, you know that it is unknown. It is not stated directly that the standard deviation is unknown. That you have to interpret by yourself. Okay. So it is very seldom that we estimate. Okay, sometimes in some situations, we do not know what's the standard deviation of the population. So what we have to do, if in the previous example, we use this formula, okay, but when the standard deviation is not known, then what we have to do, we have to use this formula in order to estimate in order to estimate the standard error of the mean. Okay, if you realize just now, right? So when we solve this problem, we don't do anything on this value, because it is given. So we just use it directly. But for the second situation here, when we do not know what's the standard deviation of the population, you have to apply this formula in order to estimate this value actually. And how to know this S value? Okay, so that one is, yeah. So that is this one is actually from the previous formula. I'll show later. Okay, but let's go through this point first. So this is the formula that we have to use later. And then just now we use Z, right? Z. So for this second situation, we cannot use Z, but we use T distribution. Okay, T distribution, which is another type of distribution. Okay, so that's the early info that you know. Okay, so, but in order for us to understand this, we have to know first what's the T distribution. So that's why in this middle part, we would cover T distribution first, okay, in order to relate back to this one. Okay, so this situation. So now let's have a look at what is T distribution. T distribution is a type of normal distribution, but what's the difference between T distribution and the normal distribution is that in terms of the mean value and also how the shape of the distribution. So it is still symmetric. Yeah. So for example, this one, if you see, this one is the Z distribution or the normal, the standard distribution, but the T distribution is this one. You can see that it is much flatter, much wider in terms of the coverage, and the value of the mean is smaller than the peak. The height of the peak is lower than the Z distribution. Okay, so this is another T distribution curve. Okay, so that's the difference. It's symmetric still, but then it's much flatter, more flatter, and also more flatter than the normal distribution. Okay, and also lower at the mean and higher at the tails. So if you see here, this is in terms of the mean, yeah, lower than the normal one, the Z distribution, and also in terms of the tail area, it's higher at the tails, means that the value is higher. Yeah? Okay, so that's the difference between T distribution and normal distribution. Okay, so T distribution is used when the population standard deviation is unknown. Okay, and it has to be estimated from the sample. And also when the sample size is more than 30 or the population is normal or approximately normal. Okay, so these are the situations where we use T. So apparently in this case, we use T because of the first situation where we do not know about the standard deviation of the population. Okay. All right. So if you see here, this is the T value formula. This is the sample, the mean sample, the sample mean, sorry. and this is the mean of the population, and this is the estimate of the standard deviation. Okay, and if you see this formula, it has a similarity with the Z. The Z is, when we talked about Z last time, this is the formula of the Z. So you can see that the trend is the same. This one is the sample mean. This is the population mean. This is population mean. And this one is actually the standard deviation of the population. But because we do not know what, in the case of T, we do not know what is the standard deviation of the population, we use this formula to estimate the standard deviation of the population. Okay. All right. So the T distribution, it has T distribution table. So I have uploaded it on Elite. You can have a look at it later. So what the T distribution table consists of, it consists of this this thing, the degree of freedom. That's what you have to find out, and also the upper tail area, which is denoted as alpha. Okay, and the values in the middle, the values inside here, these are all the T values, the T values. So these are the values that you want to look for, actually. Okay. Okay, what else? That's it, I think. So let's have a look. Maximal margin of error. So this one is just to denote that, because the thing is, now when we use this expression to estimate the standard deviation of the population, so it means that we are just estimating. It's not 100% correct. So the whole thing here is denoted as margin of error. Okay, this is just a terminology, but at the end you want to find what's the confidence interval, which is the whole thing here. Okay, so that is the margin of error. Okay. And then, okay, now, so how you want to find the confidence interval using the whole expression here. Okay, I'll just go directly into the summary here. Okay, so there is a similarity between this case and the other case just now. Okay, let's have a look. First, you have to find what's the mean of the sample is the same. Okay, this one is the same. And then you have to compute S. So this one is what you have to refer to the previous formula, which is this one, this formula. Okay, this one is the formula of variance. But then if you want to find the S, you have to find the square root of the values here. Okay, this is variance, but then you can find what is S. Yeah? So that's how you can substitute the value of this one. Okay, and then the N is the number of samples, the size of the sample. Okay, so that's how you can solve for this one, the standard error of the sample, yeah? S X bar. Okay, so after that, step 4 is to compute DF, which is N minus 1. Okay, this is quite easy. And then step number 5 is to find the T. Okay, find the T using the T table. Okay, so since you have known what is DF and what is the tail area will be given in the question. So from there, you can use this one to find T values. Okay, because you know the degree of freedom and also the tail area, upper tail area. Okay, let's go through the steps first before we go into the examples. Yeah. And then you find what's the lower limit and upper limit. Okay, it's quite similar to the previous situation. It's just that some additional info that you have to find before that. So this is the expression of the lower limit, and this is the upper limit. Okay, so just now we are using Z, right? So this one is T. Okay, so this T value is the one that you find from the T table. And then at the end, you have to construct the confidence interval. by writing this expression. Okay, see, this one is still the same, the population mean, and you have to put the lower limit value and the upper limit value. Okay, so assumption here, the sample size is more than 30, or it follows normal distribution. The scores are sampled randomly and are independent. Okay, so that is the summary of computation of confidence interval when the standard deviation of the population is unknown. Now let's have a look at the example. So this is an example of the question. A researcher was interested in estimating the mean reading speed, number of words per minute of TESOL graduates and computing the 95% confidence interval. A sample of 6 graduates was taken and the reading speeds were 200, 240, 300, 410, 450, and 600. Okay, so from this question, you can see that there is no information of standard deviation, unlike the first example just now, where the standard deviation is given directly. Okay, so from here, you know that you do not know about the standard deviation of the population. So it falls under the category of unknown standard deviation. Okay, so what are other information that you got? So you got a sample of 6 graduates, and these are the information. So now, if you see, you might be confused that the sample size is not 30, but you see that this one is actually, this is the situation. It is a normal distribution, and you can, I mean, there is no information of the standard deviation. Okay, so that's why you can use this case. Yeah. Okay. What else? So what we have to do? Okay, so if let's say we want to apply all the rules here, yeah, all the steps here. So first we have to compute the mean of the sample. Okay, the mean of the sample is quite straightforward. X bar is equal to 200. Okay, this is step 1. 200, 240, 300 plus 410, 450, 600 divided by 6. Okay, you got the mean of the sample. Okay, so that's step 1. Okay, step 2. Step 2 is, if you see back, step 2 is to compute S. Compute S. So S, you find first the S square value, which is 1 over n minus 1 summation of x minus x bar square. Okay. So this one, you have tried this formula before, right? So you should know how to use the summation things. Okay, n is 6, right? So 1 minus n minus 1, 6 minus 1 is 5. Okay, 5. And then this one is a big bracket. And then x minus x bar square. So x bar is this one. Okay, let's find the x bar is 366. Okay, this one is 366.67. Okay, now this one, the x here is referring to each of the value. Okay, so it means that you have to do one by one, like 200 minus 366.67 square plus, because this is summation. Okay, so you have to have a bracket inside this big bracket, and 240 minus 366, this is a x bar, 0.67 plus 300 minus 366.67. I hope that you got my point over here, until the last one is 600 minus 366.67 square, and then you close the bracket, the big bracket. So when you calculate this, please be careful, because you might forgot about the bracket, you might forgot about the symbol and everything. And also this term, don't forget at the end, you have to divide by 5, the whole thing inside. Okay, And again, this is s square. So you have to find s. So the final value, you have to find the square root of it. Okay, s is equal to the square root of s squared. So you will get the values. So the values here is, what's the value here? I don't have the actual value. So when you find the s value, you're not done yet, right? So you have to find, step 3 is to find sx bar, which is the standard error of the sample, the estimate standard error of the sample, which is equal to the s divided by the square root of n. Yeah, square root of n. Okay, so the s value that you got over here just now, you put it into this formula, and you'll find the value of this. Okay, I just shortcut lah. But this one is the value, the final value that you got. Okay, so means that find s squared first, find s, and then substitute into this formula. That is step 3. Okay, step 3. Okay, step 4. So now step 4, compute df. Df is quite easy, n minus 1. So n is 6, this is n, df is 5. Okay, so that's how you got this. Step 4, this is step 4. And then what else? Step 5. Okay, find t for this df using a table. Okay, now you have df is given in the question that you have to find 95% confidence interval. So means that, what's the tell area? So this is 95%. Okay, and this is should be 2.5%, and this is 2.5%. Because you need the information of upper tell area, so you have to use this, okay, which is 0.025. And not 0.05, okay? I don't get confused with that. So this is the upper tell area or alpha that you have to refer in the T table. Okay, so df here is 5. Okay, now if you go to the T table, okay, you have to find the T value. You have df 5, and then the upper tell is 0.025. So your T value is this one, 2.571. Okay, so if you use the wrong value, if you just get it 5% just now, right, and you use it directly without dividing it into 2, so you would get this incorrect value of T, which is not the right value. So that's why you have to make sure that you know what the upper tell area means, because this is upper. Upper means like on the right side. Okay, now go back here, and then your T is 2.571. Yeah, find T. T is 2.571. Okay, that is step 5. Okay, what is the next step? So now you know what's T. Then you have to solve the lower limit and upper limit. So lower limit is x. Step 6. X lower limit is equal to x bar minus the T and the standard deviation of the sample, isn't it? So here, this is x bar, 366. Yeah, just go directly here lah. This one, 366 minus the T and also the x, sx, the standard deviation that you have solved in the third step, okay, which is 60. And then you got this value for the lower limit. And for the upper limit, you solve by adding the things. So this is the value for the upper limit. Okay, and the last point is the confidence interval. So the confidence interval, don't forget this symbol is the population, the mean of the population. and is between 209.904 and 523.43. Yeah. So this is the confidence interval that you are looking for. Okay. So that answers that question. Okay. Any questions so far? So the key point here for you to find is the whole thing here. Like you have to solve all the steps here. Yeah. And so just now, if you see the first situation when the standard deviation of the population is known is much simpler. Yes. Any question? Green plane. So you have a question? Yes. I saw a hand raised just now. Okay, I thought you have a question. Okay. All right. So yeah, so that is the two situations that you have to differentiate. The first situation just now, when the standard deviation of the population is known, is quite simple because it's about Z only. But this one is a bit lengthier because you have to find what is S and then what is X, SX. Yeah? I mean, step 2 and step 3. And then the rest is quite the same. Yeah? The lower limit, upper limit is the same. It just differs in terms of the expression over here. But the final aim is the same, whereby you want to find the confidence interval, which is the range. And the symbol here is the same, which is the population mean. Okay. So I don't want to go into that really much today. I think that's enough for you to cover because I'm afraid that it might be too overwhelming for you if I dump you with lots of subtopics. Okay, so yeah, I think that's it for today actually. Yeah, so you have to know how to find the confidence interval when the standard deviation of population is known, where we use Z distribution, and when the standard deviation of the population is unknown, we use T distribution. I mean the T values. And for the second situation, you have to understand the T distribution. Okay, so the T distribution has a table. Yeah, and you have to know how to use the table. You can find the practice question by yourself. Okay, so just nowadays is you just Google it. Yeah, Google it. I don't have any. If let's say I have any extra questions, I would post on eLib, but here I don't have it. Okay, so since we finished quite early today, I want you guys to do a pop quiz. Okay, let me give the link of the quiz. So you have to answer 8 questions, and the questions are based on the topics that we have discussed in previous weeks, not today. For today, I will set another pop quiz, maybe somewhere in this week. All right, so the question covered, the questions will cover binomial, Poisson, and normal distribution. Okay, this is not a graded quiz. This is just to check your understanding on the previous topics. Okay, I leave the link in the chat box. Okay, you can join now. The quiz, the pop quiz. Say again?
I have already done the pop quiz.
Oh, you're already done. Oh, so fast. Oh, because you check the elite, is it?
Yeah, because I checked it under the same week, is it, with our previous lesson, so I thought I missed that one, so I quickly do.
Oh, okay. I just posted it today, actually. Okay, that's quite fast. Okay. So anyone, others, you can answer the question. Are you guys on the game now? Have you guys joined? Okay, tak tengok orang join ni. Okay. Yeah, you can attempt the quiz on your own. Okay. So I think that's it for today. Yeah, because the answers are given already for the quiz. I think you can assess the answers whether it's correct or not. All right. Okay, that's for your revision actually. All right, I think that's it for today. Thank you very much for your attention. If you have any question, yes?
Can I scan the QR code attendance?
Oh yeah, sure. If you have any question on the quiz, if let's say you don't understand, you can ask me. But I think it's quite it is quite understandable from the answers, maybe. Okay. All right. Thank you very much for your attention. I'll see you guys next week. Okay. Okay, I'll post if I found the questions, yeah, I'll post extra practice questions on Elite, and also maybe for the quiz for today's topic, the pop quiz. All right. Okay. Doctor. Okay. Yeah. All the best.
Thank you,
Thank you,
doctor.
doctor.
Thank you,
All right.
doctor.
Welcome. Welcome.